Hi everybody, my name is Felix Kruse. I am the head of product at Debricked, and today I'll be walking you through the Debricked tool and offering. At Debricked, we think that open source is an amazing revolution that should be cherished. What we help to do is to help companies minimize the risks that are associated with working with open source so that they can feel more confident in using more and better open source. In a nutshell, what we do is software composition analysis. But we call it next generation software composition analysis since it goes a little bit beyond the traditional definition. And in this presentation, I hope to show you why. So there are three main areas of risks that we work with. First up, of course, we work with security vulnerabilities. And the basic question there is, are there any known vulnerabilities in the open source that I'm using? Of course, we also work with license compliance, answering the main question, are the licenses of the open source that I'm using compliant with the company policy? And then the last area that we're working with is community health. And the basic question there are the open source projects that I'm using backed by healthy communities that I can assume still exist in a few years? All of these areas are then wrapped in what we like to call policy automation. That I like to describe kind of like automated test cases for open source, where as an organization you can configure what are you okay with in terms of open source risks, which licenses are you okay with using, how severe vulnerabilities can there exist in different places, and how good does a community have to be in order to allow your developers to use a specific open source project. All of this can be configured in the automation system and will be checked every time we scan your code. Let's go a little bit further into the nitty-gritty, beginning with security vulnerabilities. The main features of our tool focuses around Google's Know, Prevent, Fix framework, where firstly you need to know about the vulnerabilities that you have in your software, you need to prevent the addition of new vulnerabilities, and lastly fix or remove any vulnerabilities that you already have. So at this point, let's go ahead and jump into our tool and show you what it's all about. First up, this is a web application. You connect your code either by integrating with a CI system, or for GitHub, you can also install an GitHub app straight on GitHub and connect your repos that way. When logging in, the first thing that you see is a very high-level overview where each repo gets its own row, where you can see the total amount of vulnerabilities, their priority, if they are critical or have a high priority, and some workflow-related statuses where developers or security experts can look at each vulnerability and determine if they are affected or if they are unaffected, and then there are some other statuses that we'll dive more into later. Going into each repo, you're first up presented with a list of all vulnerabilities that are present in this repo. Each vulnerability, you can see their identifier, when it was discovered in the customer system, the criticality as measured in CVSS, the affected dependency, and then again the workflow related statuses of these vulnerabilities. If you go into a vulnerability, first up, you get information about the vulnerability that we have sourced from the sources that we use. In this case, we found this vulnerability both on the GitHub Security Advisory and on the National Vulnerability Database. And of course, we can link users to both of these sources to verify where we found the vulnerability. The user typically spends a little bit of time understanding the vulnerability by reading the text as provided by the sources. And then moving down, there is the possibility to set a review status for this vulnerability. The review status is unique for the repo vulnerability combination and can either be unaffected, vulnerable, or you can pause the automation rules that I spoke about earlier from triggering from this specific vulnerability repo combination. More on that later. Moving on, you always get the context of how a vulnerability was introduced to your system. So in this particular example, we can see that the developer has imported the dependency Nightwatch, It in turn depends on proxy agent, which depends on pack proxy agent, and so on. And a few layers down, we have the indirect dependency netmask in version 1.0.6, which is the vulnerable dependency in this case. You also see the vulnerable versions of this dependency. In this case, all versions smaller than 1.1.0 are vulnerable, and all larger versions are safe. So to figure out how to resolve this vulnerability, there are two main ways to do that. A little bit of background knowledge is that to solve an open source vulnerability, you almost always do that by updating your open source to a newer version. So one way to do that is, of course, to manually look at this dependency tree, realize that you need to update netmask to version 1.1.0, and then manually do that in your package manager or in your code. The other way to do it would be to utilize our automatic fixes, which are performed by opening a pull request to, today we support GitHub and GitLab. And I want to show you a little bit more deeply how these work. So what we're looking at right now is just another example of a dependency tree, just like the one we saw in the UI. In this instance, Gravatar is the direct dependency, the one imported by the user. And 2 layers down, we see the vulnerable dependency Yargs parser in version 2.4.1. The smallest safe version of this particular dependency is Yargs parser in version 13.1.2. Now, what a lot of tools and a lot of users oftentimes try to do is to directly update Yargs parser to version 13.1.2. The problem with that is that Yargs in version 7 has no way of dealing with Yargs parser version 13. So if you directly update the indirect dependency, everything upstream will break. What our system does instead is it firstly checks, is it possible to directly update the indirect dependency? Is that permitted by the version constraints of the upstream dependencies, in this case Yargs? If that is not possible, most often due to it being a large version jump like in this case, we instead look at what is the smallest version that we can do to the direct dependency so that it finds a version where it contains a safe version of the indirect dependency. In this case, we would bump Gravatar from 1.8.0 to 1.9.0 since it has a larger version of Yargs, which has the safe version of Yargs parser. And if we go back to the UI and we look at this particular example, remember we had netmask in 1.0.6, it needed to go to 1.1.0 or larger. And I prepared a pull request which does exactly that. Firstly, when looking at the pull requests, our pull requests contain all of the information that is present in the UI. And the thought is that developers shouldn't need to touch our UI all that often. They should be able to do most of the work and read up on most of the information directly from their source code manager or their CI system. But if we go in and look at the files changed, you can see that in this case we updated Nightwatch, which was the direct dependency. And the result is that netmask went from version 1.0.6 to version 2.0.2, which is well in the safe range. And in a nutshell, what this solution means is that we can guarantee that we will not break your upstream dependencies. So we won't introduce breaking changes by breaking the dependency chain. However, it's important to note that there's always the risk of breaking changes being introduced because something changed in the code between version 2.4.1 and 13 in this example. A variable name might have changed or whatever it might be. But those are the two main ways of actually solving vulnerabilities using the Debricked tool. One being, again, the pull request that you can create from our tool, and the other being to use the context and the information that we give the user to go into your package manager and manually update your vulnerable dependencies. The last part that I want to go through just on this site is, well, there's some more information going down. But it's good to note that there is always an activity log. We log all of the behavior, all of the actions taken by our users. So there's some accountability where you can't just mark yourself as unaffected and move on. And admins, of course, can also enforce that type of behavior. So if you mark yourself as unaffected, admins can enforce that you have to leave comments on why. That covered two of the three parts that I mentioned is important in looking at security vulnerabilities. So we've looked into knowing where do I have vulnerabilities, in which repos, what vulnerabilities do I have, and how to fix them. The last part that I want to show you is about preventing new vulnerabilities from entering your system. And for that, we have the automation system. So here is the landing page for our automation system. Here are a few rules that are already created, but I think the best way to show you what is actually going on is to create a new rule. And as a user, you can create a rule for a single repo, for multiple repos, or for an entire organization. Creating rules, this is an if this then that type system. So what you can do is to start building the rules the way you like them. So for example, you might create a rule saying that if the CVS score, so the severity of a vulnerability, is at least high, then I want to fail the pipeline because I don't want this to reach my production environments. But I want to ignore any vulnerabilities that we have marked as unaffected in the UI. And if I generate this rule, I get a rule saying if a dependency contains a vulnerability which has not been marked as unaffected, where CVSS is at least high, then fail the pipeline. And so this will be run every time that we scan code. And we scan code every time a developer pushes code. But this particular rule might be a little bit harsh. You might have a backlog of vulnerabilities that you have yet to work down. And enforcing this rule might mean all of your pipelines grind to a standstill if you have previous vulnerabilities. So you might want to modify this slightly. You can do that by adding an and statement. And one thing you can do is adding the statement and dependency is new. And then we get the same kind of rule, but instead it says if a newly added dependency contains a vulnerability, etc. And then we check the same kind of rule, but it's only enforced if a user tries to add a new dependency and that is vulnerable with a high criticality severity. Some users may still think this is a little bit too harsh, as they might want to allow developers to play around on their development branches however much they want, and only enforce this in higher level branches. And so then you can introduce yet another and statement and say, well, yeah, but only enforce this on our main branch. And then again, you get the same type of rule, but it starts with if a newly added dependency in the branch main, and then the same rule. And so there are really a bunch of things that you can do with this, and I can't go through them all in this demo, but I think the main takeaway is that it's very configurable. You can set up most rules about how you want to deal with open source risks in this system. And as outputs, you can either fail pipelines, you can send warnings in pipelines, you can notify user groups or individual users by email. And you can also trigger webhooks, which allows you to hook this system up to any other system, automatically posting messages in Slack or issues on Jira or any other system where you might want this type of information when a rule has been triggered. Now, this is kind of how this would look from an admin perspective, how you would set this up. So the next logical question is, how would this look for a user? And so if I go into my GitHub account and I go into a repo, I mentioned that we do a scan every time we push code. And in GitHub, this will show up as one of these checks. And this one failed. The user can go into it, and what they'll then find is that we found 32 vulnerabilities. And then we start checking all of the rules that were created for this particular repo. Again, kind of like automated test cases. So this rule was checked and it passed. It didn't trigger any conditions. And here are a bunch of rules that passed. Here we have a rule that sent a pipeline warning. And then lastly, here's the rule that failed the pipeline. So it's very similar to the one that we just created. If a dependency contains a vulnerability which has not been marked as unaffected, where CVSS is at least medium, then failed pipeline. And the user gets all of the conditions that trigger this rule. So as a developer, you really don't need to go into the UI all that often. You can write code, push code, Debricked will scan your code, and if there are any policy violations, you will instantly get them. You can click the links. It'll take you to our UI where you can read about the vulnerability, open a fixed pull request, and deal with the problem. And so with that, I think I've gone through the main three areas of vulnerabilities. This automation system applies also to our other risk areas, which is the next area I want to talk to. So let's just briefly go back to the presentation. So looking at the feature set for license compliance in our tool, there are three main things you can do. First up, of course, you can know about the licenses in your software and also prevent the addition of new unwanted licenses using the automation system. But you can also export license reports, which are typically used for due diligences or any other legal checks of the open source licenses as used by a company. So again, let's jump into the tool and have a look. First up, we have a license-specific view. And before we start dissecting it, one thing about the tool that could be good to know is that you can always choose to view any areas directly from the left menu, which gives you a page where with, in this case, all licenses for all repos that are integrated with this user. And you can also always navigate through a repo and get a list of only the licenses that applied to this specific repo. This also, of course, applies to vulnerabilities. But in the license view, first of all, you get a list of all licenses that are used, in this case for the entire organization. Then we show you the risks of the licenses for these different repos that are using it, and the different repos that are using this particular license. You also get the number of dependencies across these repos that are using it, and which license family the particular license belongs to. The license risk is an interesting point. What we do is that we grade the risk of the license from critical, high, medium, or low. The risk is based on the combination of the license itself and then how the code is distributed for the different repos that you have integrated. So in another view, you have the option for each repo set the use case of how you actually distribute the code. So if it's not distributed, only reachable through a network or a cloud service, if it's only used internally, or if it is distributed and maybe even in a customer or consumer electronic product. And based on these use cases, we can determine a risk, again, low, medium, high, critical. It is important to note that we are a tool provider, we're not lawyers, and how we typically talk to our customers about this feature is that it's a great way to give a hint to engineering that if the risk is not low, maybe they should check with legal if they should do any further investigation into a particular license. Of course, you can also click on any license and get a view where you see exactly which repos there are dependencies using this license in. And clicking on any of the repos will take you to a view where you can see all of the dependencies or open source projects using this particular license, Apache 2.0 in this case. Going back to the license view, the last feature is that you can also generate a report. Clicking this button, an email will be sent to the logged in user containing a report of the licenses used. The report itself is quite straightforward. I won't go into too much detail here, but you get an Excel report showing you all of the licenses you use, the repos you use them in, and then you can see for each license more information, which repos are used, which repos are using it, which dependencies are using it, which version of each dependency is detected in the system, and so on. And so this is kind of the know part of licenses, knowing about the licenses you have, and the export part. And going back then to the prevent part also for licenses, we again have the automation system. And in a very similar fashion to vulnerabilities, you can set up rules stating, for example, that if the license risk of any given license is at least medium, then fail the pipeline. And just as with vulnerabilities, you can configure this to be only for new dependencies and all of the things that we looked at for vulnerabilities. You can also create rules based on license family, or for a specific license, say that you don't want AGPL licenses in your repo, you can create a rule for one specific license or a set of specific licenses. Like I can add GPL 3.0 to the list here as well. And then you get that rule. So that is in a nutshell our license functionality. It could be good to know that we have more data under the hood that has yet to be put into the product, and we will be evolving the license offering of Debricked in the future. And this brings me to the last area, which is community health. And community health is, as I mentioned earlier, about understanding the risks associated with the community building the open source that you're using. And the three main use cases here is understanding the community supporting the open source that you're using, being able to choose better open source to begin with, and then again preventing the addition of unmaintained open source through the automation engine. In full transparency, it's good to know that the choose part is the developed use case, whereas the understand and the prevent part is still somewhat under development. If we look at the choose part, we have a section of the tool called Open Source Select. This is an open database. You can use this without being logged in. However, if you use it while being logged in, you get several advantages, such as having the data being contextual to your repos and having your automation rules being applied to the searches. But in this database, you can search for open source projects. So let's, for example, search for React. React will show up, and you can instantly see which license it uses, as well as some of these open source health scores that we'll be diving more into. And the open source health scores are about measuring the aspects of open source that you typically try to investigate anyway when you're choosing open source. But instead of having to dig through a bunch of GitHub information, it's nicely presented for you in a UI. So, for example, we rate the contributor community of React as 75 out of 100, and we base that off of the key questions that you typically ask when evaluating an open source project. So, in this case, we can see that the contributors are very experienced that are working with React. Maybe they're lacking somewhat in efficiency, it being 60 out of 100, but it's a nice and diverse community, meaning that it's a lot of people working on it, not just one guy's hobby project. Contributors are active, the core team, the people with merge rights are active, and contributors typically stay for quite a long time with this project. They don't just do one contribution and then move on. We then show the same type of information for popularity, like how popular this project from a few different dimensions. And we're currently working on more metrics to put in here. So currently this can be used to investigate open source that you want to start using or you're considering starting to use. The next step for us is to do two things, which is one, including this type of information on the scans of the open source that customers are already using, so getting it into the core tool. And then two, applying the rules set by the automation system to the searches. And this is quite a cool concept because that means shifting further left in the development process in ensuring compliance with the policy set up by an organization. So if I were to search for React, for example, and for some reason Apache 2.0 is not a license that we want to use in the repos that I'm working on, in the very near term future, an alert would show up notifying me that there's no point in you importing this dependency because it won't pass our pipelines anyway. Last part that I want to show you about the open source select is that what we've looked at is kind of the search engine functionality. We are also building comparison functionality. So if you want to compare React to Angular, for example, you can search for Angular and you can compare the two. And you get a nice overlay where you can see that the contributor activity, for example, is way stronger in Angular than it is in React. The diversity is slightly stronger in React, and the experience also looks slightly stronger in React. So it's a way to quickly and easily comparing different projects. We do still have an alpha tag on this. It's still quite a new project. We're actively developing it. But this is, we believe, a really big step in helping developers finding relevant open source to use with high quality. I have one more slide on the topic, which is just kind of diving into how we arrive to these different metrics. And in the background, we have a model which starts off at the top level metrics where we had the contributor score as an example. Then again, we had the questions that you may ask. And these are all built up of both can be simple data points, such as the recent amount of commits and the commit trend. And it can also be more complex data points, such as we have this one, for example, which is contributor influence, which measures for any given contributor, how big is their reach, how many followers do they have whenever they open a pull request, how many eyes are there on that pull request. The metrics are also compared within different slices. So there's a core question of, for example, how many stars is a good amount of stars? And the answer is, it depends. If you're looking at a big front-end framework like React or Vue, you want hundreds of thousands of stars. But if you're looking at a niche research project, maybe 10 stars is really good. And so for that reason, we're not comparing all projects to each other, but we're rather comparing different verticals to each other because what is good is relative depending on what you're looking at. Popularity and contributor are the two metrics we have right now. We will also be rolling out security quite soon. It's looking like it's coming within a month or two. And then we'll start to measuring also how good communities are at working with security. So how fast do they solve vulnerabilities? Do they follow secure coding best practices? And those types of questions, which is a completely new way at looking at open source security. This presentation is mostly about functionality that is already available and ready to use in the Debricked tool. I do want to make one exception to that and talk a little bit about our philosophy when it comes to vulnerabilities and where we are heading in that space. And I think the key thing that we believe is that we want to give our users as few results as possible while still not compromising on the security that they get out of it. It has shown up time after time that a main concern with developers with security tooling is that it gives more results than it needs to. It gives alerts where it really shouldn't. The classical boy who cried wolf scenario. And what we're doing with that can be represented in this funnel. The two top tiers here are kind of how the entire SCA space works today, where most vendors, first up, they collect large data sets on open source vulnerabilities, and then they match these to their users' components, just saying, you have a dependency in a certain version, that dependency of that certain version has a few vulnerabilities, therefore you're vulnerable. Fundamentally, we don't think that is enough, and so we're moving on to two more steps, where the first one is figuring out, all right, but which part of that open source project is actually vulnerable? Which method or which class? And then, are you using that method or that class somewhere in your code base? Is that method called at all? This project is really closing in on its final development stages. We're piloting it with a few customers right now and hope to be releasing it for Java quite shortly. But then there's another interesting question that shows up after that, which is, all right, so now I know that I'm using a vulnerable method, but is that method actually executed in a runtime environment? Is that executed in production? This is also a problem that we're working on. It's a research project, and to be quite frank, it's probably at least a year from production. But I think it gives a hint on where we want to go. We want to make the funnel as narrow as possible so that in the end we only spit out a few results, but the users know that when Debricked says here's a vulnerability that you need to look at, you really need to look at it. And that's where we're going.